Hello and welcome to another video. So this video is not a full tutorial in itself, and you'll notice it's come out alongside the first part of a fairly lengthy series of tutorials. And this video, the idea of it is a very short intro for if you're just wanting to dive into the system, to grab the Unity Package Manager package that is available for this, and to show you sort of what's actually involved in that. So what the series is, and what I will be doing is in the description below, as well as a link to the Unity package. I will also be including a link to each of the parts of the series as it comes out. So what the series is about is a hybrid version of a goal-oriented action planning, or GOAP. So this is something where if you've followed the channel for a bit, you might have seen other videos of mine implementing things like a monolithic version, and also a brief bit implementing a microlithic version. And in both cases, I was never sort of fully happy with either implementation. I've always felt that there was ways of sort of finding a good middle ground. And that's what I believe that I've done with this. So what I've created is a GOAP framework that is largely supporting that monolithic style of an action can fully complete a goal. However, there is support for the actions being state machines, and I've put together a fairly comprehensive sort of state machine system and a bunch of predefined states that you can easily chain together. So if you're wanting to do movement, there's already a state for that. There's states for calculating where to move to. There's states for, in the examples, for doing things like gathering resources, for looking at points of interest. So I've made it that you've got these reusable sort of Lego block states, but they get wrapped within an action for actually, executing them. So the system has that as part of it. There is a lot of infrastructure to this though, because as well as that goal and action system, that goal and action system runs the state machine. So there's the state machine system. I added support for you being able to have multiple goal action pairs running at the same point in time. So AIs have resources that are available, like legs, torso, head, and actions use different resources depending upon their particular needs. So if there's spare resources, other actions can run. So there's all of that infrastructure. There is demonstration scenes there of a whole bunch of different scenarios. There is also system and very sort of overhauled system for handling the Blackboard that makes use of some key technology there to really make it much more efficient, to make it easier for tying everything together. So let's dive on in. So this is the completed project, and I'm going to head over to actually install the package. Now, the URL for this will be in the description below. And what I'm going to do is, this is a package from a Git URL. So this URL will be in the description, and I'm going to add that. So the core set of what we get, I won't install the samples to begin with. I'll just show you sort of the core elements for the package. And it's got a lot of the main infrastructure. There are going to be further updates that I do to this, and depending upon when you're watching this video, you may already find that there is a heavily updated version of this. So there will be a lot of updates that I'm wanting to be making to this. I've got quite a lengthy list. So now it does currently use the new input system. So I'm going to switch it over to that. There are, again, further changes, improvements I want to do there of making it work nicer for both systems. So we'll restart Unity and then we'll be ready to go with it. So with the setup for it, I'll show you sort of the general architecture of sort of the key systems involved first. So this will all be over here in packages. So there are a bunch of things as part of this. So in the runtime, we have this common core. So everything is split up into different namespaces to keep it sort of clean and neat. So one of the key things there is this new singleton setup. Done a tutorial on this before, so I'm using that for a lot of different ones. Makes it a lot easier for being able to make something a singleton. I've also got this Game Debugger system. So all of the AIs are set up to be able to make use of this. And this gives us a tool that if I bring this into a scene, I'll need to import the Text Mesh Pro Essentials. But it gives us a really easy to make use of game debugger that any sort of our projects are able to tap into and make use of. So I've added support for all of the AIs, but you might want to be adding support for any of your own objects. It's quite easy to integrate with it, and that's intentional. We have this name manager. So this gives us something that we can kind of create as a string, and we can retrieve it as a string. But for comparisons, for sorting, it's actually doing that via an integer comparison. So it's really fast. The same string always matches to the same ID, so it makes it really easy to have disconnected systems talk to each other through that common fast name. So our Blackboard system makes full use of that. The Blackboard system supports the Game Debugger interface as well. So if you have something that uses a Blackboard, you can easily plug that in so the debug display will show the content of that. There's a bunch of essential common things. So there's various visual assets that you can find here, some simple pieces of level geometry, some basic objects. So the smart object system from the Sims AI is in here, of having those different interactable objects and the different interactions that can be performed. All of those are here. So a lot of different resources are there. And the core of it is this hybrid GOAP system, which pairs with the state machine side of things. So out of the box, there's some template sort of base actions there that you can be building off of. And the states, we have quite a few different ones there. So there's some states there for being able to run things in parallel, for being able to wait for a time. So you kind of got those building blocks to begin with. But the key thing really to this, where you probably want to dive into, is if we go to samples, there's our hybrid GOAP sample. So we're going to import that because this is actually going to be demonstrating things more completely. So this has in it a lot of actions and goals set up. So we've got 7 different goals supported out of the box and 7 different actions. So some of these, like the gather resource, are quite involved. There's some set up prefabs for our bare bones common AI base, and then variants for the different scenes. And we've got a lot of custom states to support those new actions and new goals that we've got in the project. So if we take a look at the scenes that we've got, well, one of the ones that we have is this first person scene. You can see our debugger here. We've already got an AI present. So if I launch this, we can see the kinds of information we see in the debug display. All of those entries there under the Blackboard, those are all our fast names. So using that system, so we can kind of keep track of, okay, well, what's the state of the AI? Where is it located? We can see that at the moment it's running the chase goal, and it's trying to move towards us. This is a very windy area, so the AI could be kind of anywhere. I managed to evade them. So go and actually find them. There we go. So now they'll actually start chasing me. Now that they've found me, and they will stay close to me. They'll do their best to be looking at me because that's one of the goal and action pairs that we've got present, is that we can actually be having it be looking around. So that's good. And if it loses us, then it will switch back just to its regular wander. So it is still trying to chase us, but it lost us, so it went back to wander. So that's our first person scene, and this one's making use of, it has behaviors here for, if we scroll down, for our idle, wander, chase, and look at. If we go over to our RTS one, so we've got a couple of AIs present here. We've got all of these resources and containers for storing resources in. So these ones, as well as having the wander and idle behaviors, they can also gather resources and store them. So if we run this, then okay, well we can see variant A, they're gathering water, they're moving to the source. Now they're gathering from it, and we can see the exact progression with the state. We can see how much they're actually carrying. If we go to variant B, we can see they're grabbing food, and they're actually holding all of the food, so they're going to be heading over to the food storage. So all of those behaviors are working with this. We can take a look at our SimStar one. So in this case, I've taken that logic for being able to decide, hey, I want to interact with something, and I've brought that over into this. So we can see they went and made food. Unfortunately for them, they managed to make some very terrible food, which is less than great. But they then went and turned on the TV and are now going and reading a book. So that behavior is all working, and we can see, again, the different logic that's there and running. The final testing that we have is this village one, where we're dynamically spawning a lot of AIs. And so we've got 5 different ones that we're spawning here. They're going and doing different things. So this one's gathering wood, another one's gathering food, and others are grabbing water. So there's a mix of things that are being retrieved at the moment. So what we'll find is like the return home priority did tick up, but they didn't get quite far enough away for it to take over. The resources were close enough that they could just go and grab those. So you can see them a little bit in the distance moving around. Now, if we go and take a closer look, we may also, one of the things we'll find is that they can get a little bit stuck on each other. This is using a fairly basic version of the navigation side of things. So their obstacle avoidance is not particularly great. So they will get stuck a little bit on each other. But they are managing to successfully grab the resources, and that navigation interface that we're using is designed so that we can easily swap it out for a different setup there. So this is overriding a lot of the basic NavMesh agent logic. And it's doing that so that it can be controlling when and how the AI turns. But the downside of that is then that kind of means we need to implement our own obstacle avoidance, which these don't currently have. But we can see the gather resource priority is ticking down quite a bit for ones, which means if ones get too far away, they're going to be far more able to run that return home behavior because they'll get far enough away that it will kick in as being urgent enough. So that's sort of the core of the setup of these. In terms of what the code actually looks like, so we'll take a look at that for some of the ones. So our actual goals, there's essentially only one mandatory function that we have to implement. So that function, its entire job is to figure out this priority. So in the case of some goals, there might be more complexity to that because we might have start and stop ranges for things, so we can control what priorities we should be running, and we've got this predefined set of priorities to pick from. And we can use values interpolated between those, but these do give the bounds of what essentially our priorities are. So we do have a max and a min and a very clear do not run value. So that's stuff that's supported there. Our actions are a little bit more involved, but we can do things like, for example, with the chase, what we're wanting to do is continually get this target location and find a suitable move location. So it's continually doing that. And it's going to continually reissue the move to state. So we have support for running blocks of states in parallel. I'm generally in the code using it with just 2, but you could use it with as many as you wanted. So that's really handy if you've got logic like of this where you have, oh, okay, here's something that'll do update information, and here's something that acts on that updated information, and I want to continually cycle these. This sort of parallel state will actually handle that. We need to say what kind of resources we're using. This is pretty standard, and we need to set up the types of goals to be using. And then this is a little helper function for retrieving our awareness target from the Blackboard and then setting that awareness target as our actual sort of focus target that we're trying to head towards. So really handy sort of setup of being able to do this. If we take a look at something that is more complicated, so gather resource is quite a complex one. So it has several states to it, has a lot of these custom states, and the transitions, however, are quite straightforward. Now, depending upon when you're looking at this video, these interfaces might have changed a little bit because this is something where some future updates that I do have planned that I am going to be making are going to make these interfaces simpler and again make it that there is less logic you're having to write. And very much the goal with this is having as little logic as possible for creating your behaviors. So adding custom states and something like our select resource is a reasonably complicated one. There's not too much we need to set up, even for something that's quite complicated. It's well under 100 lines. A lot of the functions are pretty standard that have to be implemented. So it's a fairly minimal amount we need to set up for it. So the idea is as little code as possible that you're needing to set up. And again, longer term, one of the things I'm wanting to be doing with this, and this is going to be a much larger update, is adding support for visual editors for things like the state machines, for being able to assemble sets of behaviors visually as well, to really sort of thin down and make that easier to work with. At the moment, this has been a version where I've focused heavily on the behavior side of stuff, and on being able to make those actions and goals work the way that we need them to. But there is a lot of future plans that I've got for this. The sample also has an example here of wrapping and interfacing to the navigation system. So there is an interface that we need to support, and so we need to be able to bridge that to answer these questions. So this is something where if you are wanting to use different sort of pathfinding system or a different interface, you can create this kind of bridging code. And as long as you provide functions that support these same signatures, so the same mix of parameters and return values, those will be able to actually mesh fully with the AI systems without any issue. The other sort of thing that we have here that we had to set up is this is a bit of a wrapper class. Again, there's a little bit of bridging stuff for the navigation and awareness systems. So this is a focus that later on I want to make it that more of this stuff is pushed down into the core, and so it's not reliant on it being in a sample, so that it's there as just a common set of code that you have access to regardless of your setup. There's stuff here for points of interest, so selecting ones. Again, that's a good one to be moving down to a lower level, and our interaction side as well. So not too much bridging code needed, and that same bridging code is shared in all of these scenes. So each AI sort of type, each AI environment is not using a different set of bridging code, they're all using the same. So most of the focus ends up on being creating those goals and actions, and mostly that side with the actions and the state machines. So that's sort of really the overview of the system that we've got there. In terms of working with the debugger, that's something where you can actually see what happens with that. If we go to our base brain, we actually, and it has quite a lot in it, so because it's able to run multiple goals in parallel, the gameplay debugger that we've sort of set up has some standard interfaces. We can push indents, we can pop indents, we can indicate if something is selected. So at the moment, the debugger is focused on being able to work with text data, but future things that I do want to do is add interfaces here for, we'll go to our debugger interface. Not going to find it from that. That's okay. If we go to our game debugger, like that. So these are the interfaces we have at the moment. I do want to add in later on support for being able to do things like drawing for, in like as in fully in the world or as in things relative to the particular object. All of those kinds of things I think would be really helpful to support. So those are future things that are currently planned. But for now, it's really handy for displaying the text data, and that will work sort of quite reliably. You can just drop it in and it's good to go. So that's really sort of the key stuff for the project. If you're trying to work with it with the code, the main sort of things that you'll find is I've made a lot of use of namespaces and a lot of use of interfaces in abstract classes. That's a very intentional thing to try and create a stricter partitioning between stuff, and to try and have it that it's easy to go and adapt this to other projects. So I think this will work nicely as a good middle ground between that monolithic style of the action doing a huge amount and the microlithic style of the action doing a very small amount. So having the state machines kind of provide that monolithic support, I think works quite well. I do intend to, in terms of future plans of what's going to be being done, apart from cleaning up some of the interfaces there to simplify them, apart from bringing more stuff down into the lower level on the navigation side and on things like, interactions, points of interest, stuff like that. I do also want to add in support for having actions that are behavior tree based ones. So at the moment, all of the actions are finite state machine based ones, but there's nothing preventing us from setting up an action that actually is a behavior tree. So that's going to be future things that are getting added into this. And again, depending upon when you're watching this video, they may already be out. The documentation for this package is still a work in progress, and initially a lot of the documentation is going to be heavily reliant on sort of the videos. But I do want to be expanding that documentation over time. It's just going to take a bit because it's a lot of writing to actually do for it, and so that takes quite a lot of time. But I will be putting in links to the videos. You'll also find in the description below links to the various videos as they come out. Now, I very much understand with this series, it is quite a lengthy series. There are 8 videos. Some of them are quite lengthy. And so there's a lot of fairly comprehensive information there. And that's kind of why I've done this short sort of overview video, so that if there's particular parts you want to dive in and look at, I've tried to make that as easy to do as possible. So every video in the series is going to have a link to the code as it is exactly at the start of the video where I'm beginning from, and then the code at the end of it. So if you're wanting to jump into any particular video in that series of 8 ones, you're going to be able to do that. I've tried to set that up for it. The other thing I will have in all of them is there will be the timestamps marked out in the description, and that should show up properly on YouTube. So if you want to jump to particular areas, you'll have that as well. So it's not a series where I'm expecting everyone, or even probably most people, to watch necessarily the full series, because it is a lot. It's going to be rolling out over several weeks. So unless you're watching this a couple of months in the future, each part is going to be rolling out week by week over a period of 8 weeks. So it's a lot. And so completely understand that folks might want to be like, I just want to skip to the section where you're implementing the planner. And so you'll be able to do that, or skip to a section where I'm just implementing chase behaviors. That's going to be very possible. So that will be very doable. There'll be links in the description below for each of those sections as they become available, and those will also be in the documentation. Thanks, folks. I hope you found the video interesting and helpful. If you have, check on a like and subscribe. It really helps out. It's really appreciated. The link to the package is in the description below. You will also find a link to all of the released videos in the series. So there are 8 in total, and those will be linked there. Now, if you were watching this very far in the future, which you might be, then there could be other parts to this, and those will also be added into the description and part of this same playlist. Now, if you do have any questions, do make sure you ask those in the comments. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below. But until next time, bye.